Hello everyone and welcome to Handmade Hero, show where we code a complete game live on stream. I think we basically finished everything last time and we actually correctly had our program translating an input text file into an output text file while doing the import, such that we can now add things as we wish, which I do wish. I would like to add edits from the in-game editor, which allows us to edit alignment points. I'd like to have that come out in the text file when it gets translated. And so that's really all I want to do today. I want to get that working, and then we can move on to something else. I was thinking of maybe we could augment the text file to have fonts and sounds, because those are the two things that we don't have a text-based import format for at the moment. Seems like a good idea. I don't know. Anyway, let's take a look. So, if I remember correctly, we are the champions because if you look in here now, basegame.hha and introcutscene.hha are fully rebuildable files that you can now rebuild from nothing but this magical sources directory, and which is filled with PMGs, and tags files which say how everything should get packed. And that's it. That's pretty cool because it means we could do a full game rebuild anytime we want, and it will still have everything in it correctly, including all of our markup like tags and stuff like that, and alignment points. So that's pretty cool, and it turns out that this just kind of worked. If you go back into the game and run it, it runs exactly like it used to. Now, of course, it's running in debug mode, so it's a little bit slow, which is less good. And also, you can kind of see that, well, the head isn't there right now. Why isn't the head there? Well, the head isn't there because we don't have any alignment points defined. So heads can't snap to bodies, because there ain't nowhere to snap to. And we have an in-game editor, so if I want to open up the in-game editor, I can click on something like this body here, and I can actually switch to something where I can edit it, right? And we're in debug mode right now, so the frame rate's terrible, but you know, it doesn't really matter. I'm just kind of showing you what I'm talking about. So I can do stuff like define the point where the head should snap on, like there, and then, hey, the head suddenly does snap on, right? And I can even position that point exactly how I want to, and I can switch over to the head and all that stuff, and I can set the alignment so it's not sunk into the floor. I can do all those things in the in-game editor, but again, what we were trying to figure out is, well, okay, we need those things to persist in a way that when we rebuild the files, they don't get lost. So what we did is exactly what I just said. We now have a way of making all of that happen, and we can run a full import and preserve the text file. And so what we really need to do now is in that import where we're actually doing that whole situation. I believe, actually, now I think of it, I think it was called sync. We changed it. Synchronize asset file changes, right? What we had is in here, we would go through each of those HHT files. We'd reprocess all of them, see if we needed to load any changes or anything like that, like from PNGs or whatever. And then we can insert stuff as necessary into there, right? So you can kind of see that happening. Let me put it over here so my head's not in the way. So you can kind of see that happening here where we go through and we're doing like parse top level block, for example. You can see this copy all input up to and including was what we were using to sort of move things from the source file to the destination file while we were parsing that text file. And that allows us to insert things back into the text file while preserving the author of the text file's original formatting and comments, which is pretty cool. So we're not destroying anything like we would if we just rewrote the file entirely ourselves, right? It's kind of cool. We don't change the order of things. We don't change the formatting. We don't get rid of the comments. We just copy it directly. So if we look at what we actually need to do here, you can see here is an alignment token parse. And you can see what that does is that allows us to read in all of this information about alignment points. Now, alignment points are the things that we're trying to edit. We have the reader for them. What we don't have right now is something that actually writes them back out again. So what we would like to do is, if we've added one, we'd like to go in and rewrite it. So that's what we need to do now. After I finish my oatmeal cookie. So here is align points, right? You can see us gather it here. And what you'll notice is that at the moment, it's not even used, right? So literally, we read all these align points in. We wouldn't have even used them if they were there. And we don't write out ones that were in our current alignment set and just that we don't, that we didn't see. Okay. So the question is, what do we do about this? Well, I think the first thing we probably want to do is say, if we've got this whole alignment point thing, right? What we should probably do is let's extract all of the alignment points we currently have and put them into this HHA align point set, right? Because if we had the whole set of alignment points that we currently think are there, then we could go through and, as we read in new ones, look to see whether they're the same or different as the ones that appear in the file. If they're different, we will strike the one in the file and put the new one in, or strike the old one and read the new one out, depending on whether we're doing an import or an export, right? So we can have a flag that tells us, what are we trying to do here? Are we trying to overwrite the existing file, or are we trying to overwrite what we've got in memory using what's in the existing file, right? So we have two things we can do there, and we want to implement those. And then the other thing we want to do is, as we see each individual one, when we make that decision about okay, we've seen an alignment point in the file, either we replaced it with our own version or we read it in and used it in place of the one we used to have. When we do that operation, we also want to just record briefly, have we processed this alignment point yet? That way, when we go through at the end and look and say, all right, we're going to go look to see for each alignment point, did we ever see this alignment point in the file? If we're writing out our alignment points, then what we want to do is take any of those that didn't exist in the file and add them into the file. If we're reading in alignment points, what we want to do is take any that aren't existing in the file and clear them so that they're not in our HHAs anymore, right? So we have this two-way thing, right? We just want to synchronize these, and we're going to be told by the calling code which way to synchronize. Are we writing out to the file, or is the file coming into us? And one of those two things will be true, so we'll know how to merge the data. Merge is probably the wrong term. Update the data is probably the correct way to say it, because obviously we have a situation where one or the other is going to be primal, and we just need to know which one it is. Now, this is the only thing that operates this way, because at the moment we don't actually have any edits for anything else, and we don't really need edits for anything else. In the future, I could see us maybe wanting to allow tags to be edited in the game, so that you can tag things more directly that way. Maybe, right? It's just unclear that that's really all that useful to a certain extent, because since we can just open up the text file and edit it in there, I'm not sure what benefit it really has to putting it into an editor. It seems like kind of just a waste of time. Alignment points I don't think are a waste of time, because they're a visual thing, and so you want that instant feedback so you can just dial in the exact point you were trying to set. So I feel like alignment points make obvious sense, whereas I feel like anything else that you're adding editing for is really just gratuitous. So why bother, right? That's my thinking on it at the moment. It may change, we'll see. But that's really so all we're going to be focusing on is that. So if you take a look in here at how this alignment point gets read, I want to change this align point written part because that's maybe, well, I mean, I don't know if it's really, I'm just talking about the name. I want this Boolean, I just don't know what I want to call it because written is a little bit of a different, is probably not right. I think what I'm trying to say is align point processed, right? Like, have we gone through and done something with this alignment point yet? Whether that's reading or writing. So that, I think, is just a better name for it. But let's go back in here now. So when we process one of these align points, what we're going to do is say, all right, here's all of the data that comes in for that align point. You can see me grabbing it all. There's the grid X and Y, there's the index, there's percentage size and type, these sorts of things. So when that read occurs, what you can see here is we're going to issue an error if you tried to say an alignment point that we don't currently have. Otherwise, we're going to process it, and also if you have the two parent specified incorrectly or something, we'll issue an error there as well. Assuming that we got to the end okay, then we're going to be actually writing out this alignment point into the array. You can see me doing that here. I get it at the grid, grid X, grid Y, and then which point it was, like this. And you can see me setting the things there for it. So we've got the P% getting set, the size, the type, right? And so what I want to do here is also, in addition to that, I want to say that I processed this one. So in here, I want to say align point processed, and I want to say that this one was processed, right? It's a true, so that it was processed. Now, there's a couple of different ways that we could do this, and I'm not sure how exactly we want to do this. Because there's an inverse way we could state it that might be a little bit more sensical. And I'm kind of leaning towards it. I think I might want something more like this. So anytime we see align point, we say align point unprocessed equals false, rather than align point processed equals true. And so in here we set unprocessed equal to false for everybody. And then in here, we would have, right, we're going to have a for loop that reads these alignment points in from their current setting. So for example, we'd have something like this. So we've got an iteration through the grid, and we're going to set align point unprocessed equal to true for anybody who's actually got one of these alignment points currently. So we need something that looks like this, right? And there's going to be an if here that checks to see whether the thing exists currently in the bitmap itself, right? So this needs to do a lookup, grab the information that we actually have about this particular sausage element right here, right? And what we'd like to do is then, from that, we would like to say whether or not it's got one. This way we start out knowing what they all were. This allows me in here to say, okay, when we go through, I can set align point unprocessed such that we can mark all the ones that we saw inside the text file. And then at the end, we can go back through these and see which ones we didn't process, right? So we've got one loop over them there, and then we've got another loop over them here, where after we're all done with everything, we can put it all in there. So you can see us having it, we've got it right here where we do where we see the close brace, before we copy everything out, we can insert any ones that we didn't already see, right? So it's going to look something, you know, like this. Oops. If one of these things was unprocessed, you know, and should have been, right? Then we can decide what exactly it is we're going to do with it. If we were writing out this file, then what we would do is we would replace we'd insert all of these ones that we're missing. Whereas if we were doing the opposite, we would clear them. And so that's really all I'm talking about, right? So we set it up. We say, look, let's remember all of the things that we actually that we already have. Let's track them as we see them in the text file, and then at the end we will go ahead and rewrite the ones that we should change and/or clear in the HHT, in the HHA, the ones that we didn't see, depending on whether we're importing or exporting, right? Hopefully that makes some sense. So it's a little bit complicated to do that. Obviously, it's just a bunch of bookkeeping. If you look at what's going on here, you can see that inside match, we do a get or create asset source file. And so this match right here, that is really the thing, that asset source file there is really the thing that we're looking for. So if we go to asset source file, you can see in here, we assert that we've actually got one. And so in the case where it's is default, we wouldn't, but otherwise we always try to get one. So basically we're only going to need to do this processing if we actually have somewhere to store it. If we don't have anywhere to store it, then this is all academic and we're going to be outputting errors anyway. So you don't really need to worry about it. So inside here, we're going to say, look, did we get one of these files? And if we did get one of these files, then what we want to do is take a look at the asset indices involved, and that will give us the asset in question. So if we go ahead and look here, we can say, all right, we know what the asset index is for any particular grid location, right? Oh no. Wait a minute. This says it's YX. Is that how we have been doing it? Oh, yeah, it is. Okay. Whew. Sorry. My bad. I got nervous there. I thought that, like, I had commented it one way and did it the other way everywhere. But no. It was only just now that I was not obeying the convention. So we can go ahead and grab out any given one of these asset indices. So here's that asset index. We can check to make sure that the asset index exists. If the asset index doesn't exist, then we don't have to do anything because there's nothing to load. So just a completely empty version is actually what it should be, and we're not going to mark it as something that's been used. So in here, after I look at the asset index, if we actually have one, then I want to do a actual access of that asset. So I need to do like a get asset call, and I need to say, give me this particular asset, please. When I get back that asset, I could double check again that it's there, although really this is I probably shouldn't check. This is an assertion, really. If for some reason that value was wrong, that's not like the kind of error that we're talking about where it's like user error. That's an actual just hard error in the system, because that means that our import, like our actual like asset loading code is broken and needs to be fixed. That's not an actual soft failure that like somebody typed a character wrong in the HHT and we just want to report it. It's not that kind of an error, I don't think. So that should be a hard fail. Someone needs to do some debugging if that ever occurred, because if this asset index is an actual number, like, you know, not 0, then it should absolutely exist in the asset array. It's not legal inside our system to have an asset index that points to nothing off in the distance, right? So anyway, once we get that asset back, now we should be able to verify that it is in fact a bitmap, right? So we should be able to do a further assertion that basically says, in addition, if there was something here, it should also be a bitmap, because the grid only stores bitmaps. So the asset type here should be an asset bitmap, type bitmap. And if it's not, again, that's just buggy and we need to fix it, because the grid is, you don't import anything else into the grid, right? Does that make sense? Now we may relax that restriction when we go to do sounds. We're going to have to see how we want to address that kind of an asset change. So we may need to, like, we may need to sort of adjust the way we're doing things here as we move towards different types of assets that are being imported or exported, right? So we do have some things that need changing there, and we'll kind of, as we grow the asset system a little bit, we'll have to work that out. But anyway, assuming that right now we just say, look, we're only doing bitmaps, and so the asset has to exist, it has to be a bitmap, and we just want to error out otherwise. Once we have that done, then inside here, we do know where the data for all this stuff goes. It's in here, right? And so in here, we can just look to see, does a particular alignment point exist or not? And in there, we can basically use the file formats calls. I believe there's one in there somewhere here. It's just the type, but so I guess we should just look at the type. So in here, if we look at the type, the bitmap align points have these. So I can basically say, all right, if the align point in question, whichever one we're looking at here, if its type is none, then it's not going to be used. So if it's not equal to none, then it is used, right? So when loading these in, it's just that. This is the entire code here. This will go through every grid square. It'll say, if there was an asset that we know about that exists inside this grid square, in terms of an import, we will remember that that's happening, and these are the align points that it had, right? So we'll set on process equal to true, and then we just need to actually copy out the align points as well. Now, we could do this a little bit more straightforward, I suppose, if we want to, by just using a copy. Since we're already looping through it, I don't really see the need. We might as well just actually do it manually, because why not? So in here, we can say, look, copy out in addition that whole bitmap align point so that it's stored in here, and we can now fuss with it, right? So that extracts all of the bitmap alignment points into a temporary holding place. And the question that I guess I would ask now is that really what we want to do? Is there any reason to do that? Because we don't really need to avoid touching this. If we're writing these out, then we want to update the HHA anyway. So I guess the question is, do we need to do this copy or not? What I'm going to say is, let's do the copy, because the other option, right, would be align points could just be a pointer, like, into the HHA, right? So we could just point into the HHA's version of the alignment points and say, that's the thing that we're going to be operating on, and we don't really need to store it as a separate copy. The main reason not to do that is just because this is a user editable file, right? So, I mean, user is the wrong term, because, we really mean developer edited file, but a wide number of people might edit these files, especially, if kind of the point of Handmade Hero is learning to program. Someone buys the game and they start messing with the HHT file. We want to be able to produce relatively straightforward error messages, and we don't necessarily want to, break the in-game data if you did like a partial import. So one thing we might want to do here is just, if the parse of this block did not succeed in its entirety, meaning if there were any parsing errors, we may just not want to write anything back, right? And so if that's the case, we probably don't want to directly modify the alignment points in memory. We want to avoid doing that for any block that didn't successfully parse. So I'm guessing that the best thing to do is to do the copy here, even though we could have just made this a pointer and gotten rid of this extra part of the array. Again, I'm kind of just like 6 of one, half dozen of the other on it, but I do think that that maybe makes a little bit more sense doing it this way. So inside here, again, we do have the ability to do exactly what we did here, which is, get the asset and write it out. We're going to have to think for a minute, though, because if you look at what goes on here, before the asset has actually been imported, there's really no way that we can do this clear alignment points in the HHA bit. So this is really the we're just trying to output the alignment points or clear them in our temporary array. We're not actually going to access the asset, and the reason is because the asset hasn't been created yet, right? So we're just modifying our temporary array, and later on we will figure out what we want to do about that. So if we were trying to write an HHT out, then what we would want to do is write this out like the string, right? We want to put out the strings here. So in order to do that, that's not really that hard. One thing I do want to do, though, however, before we go any further, is, again, want to just double check that we didn't have any errors. In fact, I guess I don't have to do that because we would have broken out of the loop if we had an error. So this is fine, and we can do it. So when we come through here, what I want to do is say, all right, if we were writing this out, here's where we have to sort of print this out. So this is like our printout part. Here's the part where we have to clear it. Clearing it's pretty easy. It's just going to be like, this. We've got a null alignment point. We want to romp over one that already exists. So align points, grid Y, grid X, point index should now equal null align, and we should be done. So at this point, all aligned point unprocessed, any one that was set there, we have nullified, and so now they won't actually come through in the HHA when we update the HHA later on for each individual asset. So we'll look at that in a second. The more important part here for our purposes at the immediate moment is we need to have the alignment point output to the HHT properly. That's going to require us mimicking the pattern that we talked about. Where is that for parsing? So this thing right here, right? So this pattern has to be essentially duplicated and in the reverse. So instead of parsing it, what we want to do is now we want to write it. You know what I'm saying? So we want that whole thing to come out properly. I believe this has to be like that, yeah. And so in here, we need to start sort of changing this to actually write these out. So when we need a thing that outputs to that stream. Now, fortunately, we've already got outf, which I believe is exactly what we want. So we should be able to say, look, let's do all of our outfs here so we can write this stuff out, right? Okay. So what we'd like to do first is say, well, these align points are things that we're just updating in the file. So we'd like to do a copy all input up to and including of this close brace. Only problem is we don't really want the including. So we want up to but not including as a separate thing, this token. So basically the same call that we're using to copy things in, we want that to be able to work without including the token that we're talking about. And that way we can actually do this insertion here and then copy all the rest of the stuff, right? So we don't want to include that close brace. We want to include everything up to the close brace. Then we want to do our grid copy. Then we can copy whatever's after it. Right? So we're basically just squeaking in the middle there, and it should be pretty easy for us to do that because if we just look at this function, it's really straightforward. It's the same exact thing, except instead of doing this, we just do that, right? So we don't really have to do anything. All we have to do is just take the exact same function and slightly modify how we were actually doing it, right? Everything else is exactly the same. And we could, if we wanted to, make these be, sort of, I don't know how you want to put it. We could unify them, let's say, by just adding an extra here. Because you can see the only difference between these two routines is that one of them adds the token text count. And so what I could do is I could do it like this, where we just say, you know what, these two routines are exactly the same. The only difference between them is that this one passes this, which is the number of extra characters to write in that case. Makes sense? So that way, these are both identical. There's no duplicated, cut and pasted code that, might get out of sync or something there. So all we need to do is just say, look, it's going to do the exact same thing each time. The only difference is one of them takes the actual token's size and uses that. The other one doesn't, so it just stops at the beginning of the token, and then we're done. So that makes those two nice and versatile. So we can do whatever we want with the two of them, but they still share the exact same code, so we don't have to worry about, changes in the future accidentally breaking one of them and not the other or whatever. So inside here, we now have to finish how we're going to actually output this point. And if you look at how it's working here, we need also, you can see it reading here, the open bracket, close bracket, so on. So we need to write out a line, this right here. We need to write that out. Oops. And then we need to write out open bracket, a close bracket, and a integer, right? Another one, and another one, right? The x, y, and index we need to write out there. And, I do wonder if we should read and write these in the same way that we're reading and writing them internally. I kind of feel like it should look like that, probably. So I kind of think maybe this should be, because just to be consistent, it'd be weird if our file format is different than the way the code works internally. There's no reason we can't do it that way, but it just seems like you want to keep everything working the same way, just to make it less cognitive overhead. Once you learn one way, you don't have to learn another. That would be my suggestion. But so then what we've got is open bracket, number, close bracket, open bracket, number, close bracket, open bracket, number. Oh, nope, that's wrong. It's a comma. Well, that makes it... yeah, I don't know about that. I feel like it should, again, I feel like it should look the same. You know what I'm saying? I don't know. Now it's tough. Because if we do that, it's x, y. You wouldn't do... All right, I capitulate. It should be different. If it's a comma, it won't be the same either way. All right, it's fine. I'm fine. Don't worry about it. I'm not going to get grumpy. I'm already grumpy. All right, so we've got the x and y, and then we've got the point index. Fine, I'm a little unhappy about it, but it's fine. And then we've got an open brace, closed brace after an equal sign here, right? So it's that. And we've got some commas. So we've got the p%, the size, that sort of stuff, right? So we're doing p%1, p%2, and the size, and then the type, right? And that type is probably going to be a length string, but I think we added our own specifier for those. So that we've got a percent large s. So UUS there, everyone's happy. Then we have a question about whether or not we would use toParent or not, right? And then that's the end of it. So it will look like this, but then there's also a question here, maybe we include toParent, maybe we don't. And so we'll have to have that part specified cleanly as well. Okay, so what do we need here? Well, we needed the grid X, which we have. We have the grid Y, also have. We've got the point index, that's good. And now we need all of the actual alignment point data. That would be like the point dot p%0. So these are the things that come out of there. So we'd have the p%1, the size, and then we would have the type, which we want to turn into a string, right? And then we would also have an is it a parent thing. So we do this, which is HHA align to parent. And if it was to parent, then we want to append something. And if it wasn't, then we don't. And so I'm just going to use this little trick. I often do this where I'll use the format specifier to stick a string on the end. And then I just won't stick any string on the end in the case where the thing isn't true, right? So we can do this and append that to parent flag as necessary, but we won't append anything in the case where it's not. So really the only thing we have to do here is turn this thing into a string. When we do that, you can see getting a line point name from type. You can see that happening here. So we want to go ahead and get that like so. I'm not really thrilled about the way this particular function works here because the align point is a little bit hairy. Let me explain to you what I don't like about it. It's a little bit nuanced. But one of the problems that we're going to have is when you're looking at alignment point, oh, well, you know what? Maybe I already did it, though. Yes, I did. Okay, never mind. So I'm fine with it. I'm a little bit ahead of myself. So this get type here is exactly what I wanted because what I was trying to say is I don't like the idea of not knowing how much stuff I have to and off in order to figure out what the type is. But it's okay. I did actually add an accessor for that. And in fact, I even added an accessor for this. So those kind of finicky rules there that are maybe some things we want to change in the future, I did add actual ways of accessing them more properly. And so that's great. And that makes it easy to write this code with some confidence that it won't break if we change how these things are encoded in the future, which is what I was concerned about. So anyway, inside here we've got a line point name from type with a get type. That's exactly what I wanted. And that we got the is to parent there. So all I really need now is the actual alignment point itself. So here's the HHA align point. That's just going to come out of align points grid y, grid y, grid x, point index, and now we can do that export process, right? All of this is just what I was using for reference. We don't actually need it for anything. So out it comes. And then again, if we were actually trying to import from the file, we don't want to do this, this writing out. Instead, what we want to do is in here, we want to clear, right? So that's what we did. Now, if I come down to the align code now, we've got a little bit more work to do. What you can see here is as we're, excuse me, as we're reading these things in, I probably want to do this as well. So what I want to do here is say, look, if we're trying to read these out of the file, then I want to actually do the copy. And if we're not trying to read these out of the file, then I don't want to do the copy, right? And so that's pretty specific. So in here, when we see this token and we've got a line, again, I'm going to want to do the same thing I was doing before. I want to do a copy up to but not including for the token that we're on in this case, right? And what that's going to do is that's going to say, look, everything up to here, I want to make sure it's in the output file if we're trying to output a file. And then what I want to do is I want to take all of this data that's in there, right? And I want to see if we're actually trying to produce a new HHT from for saving out an HHT file as opposed to loading one in. Then what I want to do is I want to copy the data in its entirety, like whatever was here, I want to copy. But if we're not trying to do that, so if what we're trying to do is just load in and romp over it, actually, I guess that's not quite true what I just said. So what we really want to do here, I guess, is say, look, we want to copy everything up to the alignment point. I want to read in the alignment point. And then I want to see whether or not the alignment point matches the alignment point I already have. So I want to do like a memory is equal call. And I want to say, all right, I've got the point in question, right, which is, going to be something like this. And I should probably... I guess I'm only going to do it if parsing succeeded. So it's probably only going to be in here, right? So what I want to do is say, look, I want to do some sort of comparison here where I say, whatever I parsed in, I want to see whether these two things are the same or different. And if they're different, I need to overwrite them if we're actually doing our save, right? Meaning if we're actually transferring the data. So what I want to do is say, well, you know what? Let's do a test here and see what's up. Let me first check. We'll create one of these things. We'll do this a little bit differently than what's being here. So we'll do this. We'll create an alignment point temporary structure. We'll set it all up, right? And we'll say, okay. Set the p%, the size, and the type. Get all those things in there. Then what we'll do is we'll say, hey, does it differ from the one we already have? So here's the one we already had. And this will tell us that, right? So it's like, we've got the one we parsed, and we've got the one that existed. Are they the same, or are they different? And the other thing that we might want to say is, well, now that I think about it, I don't really know that we do need to do what I'm about to say. Let me keep writing this and then we'll see what happens. So we're going to check if the memory is equal, and if the memory is equal, then we can just copy the entire thing. So we can essentially copy everything up to wherever we are in the tokenizer. Like so. So all that stuff will get copied, although it's actually that. So we can copy everything that we've seen because we know that this is just a duplicate and we don't have to do anything else. On the other hand, if it's actually different, then we need to do something more specific here. And that's going to require copying back, and it's going to require ignoring everything in this whole range, because we don't want to copy this alignment point at all, right? And so looking at it here, when we do this require token of a semicolon, this is actually going to cause us some problems because if the alignment point was different here, we may not even want to write it out, right? It may have been deleted or something. And so this causes a little bit of an issue for us because this require token semicolon, we need to have consumed it and potentially gotten rid of it. And so I'm not sure how we want to address that. I say. Let's think this through very briefly. There are only, I'm trying to think if there's other cases, but I think there's only two cases. There's the case where we load things in from the HHT and a case where we write things out, which is not as complicated as I originally thought it was. But anyway. So if we are loading things in from the HHT, then we never write anything anyway. So it doesn't matter what we put in there. That's all irrelevant. All we need to know is that anything that we read in, excuse me, anything that we read in is the answer, right? And so one way to think about it would be, look, this whole thing where we do any of this, right? We only really need to do this in the case where we have, where we're writing, right? So if we're writing, then we're going to do that. If we're not, then we're not. And so when we come through here, we really don't need to do any of this if we're not writing. So if we've got an HHT out file, then we have to do this work. Otherwise, we don't. We don't have to clear it because nothing would be in there. We wouldn't have set it to anything because we're not using what's in the HHA. We're reading it, right? So those two things can be simplified a little bit because now we know that, look, we don't actually have to do any work in either of these two cases. These are just for when we're rewriting the HHT, right? So the only case we care about here is when we're rewriting the HHT. That's the only time that we actually need to do anything, because otherwise we can just read everything in always, right? So you could think about this as just saying, well, actually, this looks a little more like this. We can always set the alignment points like when we read them in, and we're just not going to use those in the case where we're writing things back out, right? Like whatever we parsed in, we're not going to use. In fact, you could actually think of it this way, right? We write things out or read them in exclusively. So if we were writing it out, the only reason we care about what we parsed from the file at all is to know whether we can preserve this line of text or not. That's the only reason we're doing it, right? And then in the opposite case, we would just say, yeah, the align point sorry, excuse me. So I don't really know. In this case, if we're going to write it out, yeah, this is the part we have to do. If we're not going to write it out, then we can copy it in. And off we go. So the tough part is just the fact that we really want to consume the semicolon. And so I think I'm just going to cheese it, because since we only want it in one place, I don't really know that I want to spend a lot of time working around that everywhere for no reason. So I don't know if this is a good idea or not, but consume semicolon is just going to equal false, and so all the time it's going to do this. Right? And then in here I'll just say, hey, we're going to consume the semicolon in this case. Right? That's just, this thing does that. Right? So when we come through here and we get to the end, then we're going to consume the semicolon. So here we go. So we're going to require that semicolon, assuming that we get it and everything's fine. Then we'll go through and actually do the copying, right? So, you know, at each stage, we'll think that through. And so here, once we get here, if the memory is equal, then we can do this. And if it's not, we don't do anything. Actually, that's not true. We need to mark the fact that we don't do it, right? Now this doesn't actually, I wonder if we can actually get away with not having that, and that would also make it so we don't even really need that call, although I'm going to leave it in case we want it later. But since we've always copied up the semicolon anyway in any previous context, I think we can actually get rid of that. And so this is all we actually need to do. Although, since no, that's not true, there might be comments in between them. So let's say we keep it there. Then if we come up here, we can make another call. That ignores things. And what this would do is say, yeah, if there's an HHT out, then what we're going to do is just hard set this like so, and get rid of that, and oops. And that. That all seems pretty good to me. Oops. So I think we're okay. And I think that would actually do it. The only thing left to do is right now we don't actually use any of the stuff that we parse in. So I think that's the only thing left. When we do this call, update asset metadata, that is probably the place where this would occur. So inside update asset metadata, we would want to, as necessary, take whatever the stuff is that we are that we read in and romp it over the information that's in the HHA. Right. So if we're reading things in or writing things out, we would do it. If we're writing things out, so interestingly enough, like if we're in a writing out mode, then we just romp over it. If we're in a reading in mode, then if we're in a writing out mode, we don't touch it. If we're in a reading in mode, we do, right? So I think we should probably do this as a pointer. Meaning in here, when we get the asset index, for each asset, we're going to want to go ahead and set the information on that asset. So we want to do something like, hey, we want to take this asset. If there's a new alignment point array, then we would copy it in, you know? Like, if something like this guy, right? So if there is one of these, we would want to copy it in. Although, you know, I feel like we'd rather just do that outside. Hard to say. if you look at what's going on here, right? So we come through and we say, all right, we're parsing. We look and see if we've got a match. Assuming that we do, we go through and we update the metadata. And so it would be like right here that we would do it. Since update asset metadata is already looping through the grid, it seemed reasonable to do that here. But like I said, I'm not really sure. Passing this would be somewhat of a pain, but maybe not that bad. And so we could make one of these where we just say, all right, look, pass in one of these, and we're going to overwrite it if you pass this one, right? So it's like, yeah, I don't know. And then how would you know whether, yeah, I just don't like it. I just don't like it. So I think what I'm going to do there is I'm just going to say, look, let's put another one of these on the outside, and we'll just do it that way. All right. So if we go to update the asset metadata, then I will copy this data back in. So I'll say, all right, you know, here's the assets in question, and each one of these will get copied back. So in here, we'll say that the align points for the bitmap get romped over. This only happens in the case where we're not writing out the file. And I think that's all we want. Right, so in the case where we're not writing out the file, then we would do this. In the case where we are writing out the file, then we wouldn't. Now, it's a little bit hairy. The reason that it's a little bit hairy is just because if we're writing out the file and, you know, you hadn't seen, this block didn't exist anywhere, like in other words, this wasn't something that was ever an asset that had existed prior, you know, I don't know that you want to erase align points that were in there when you do the save. So we do have a little bit of a what does save and what does load mean problem, because on the one hand we could say that if you hit save it just overwrites everything, right? Meaning if there's a block that doesn't have a match, it like eliminates it, right? And I don't know, you know, like that's kind of going down a whole nother route. That would be like saying in this parse top level block in here where we do get or create asset source file, we wouldn't actually do a create. We just, if we were writing it out exclusively, we would just check and say, does this exist? If it doesn't exist, blow it away, right? Like meaning we'd skip it. I don't know. I'm just going to leave this for now because that sort of gets into a whole nother level of what do we want the editor's stuff to do that I don't really care about. I just only edit alignment points. So for now, I'm just going to say, let's ignore this. And we really won't talk about that. But you can see why there's like a bunch of things you could start to think about and want to potentially do as you kind of move through that space of what's possible, if that makes sense. All right, so let's take a look at our errors now. This is what? Context assets. That's why that's wrong. So that's in there. I'm not sure what the types are of these. I'm not talking about basic category. HHA asset, that's what it's called. And then asset, is this HHA.bitmap? Yeah. All right, for outf, we need to actually pass the stream, but after we do that, we should be fine. Memory is equal needs the size, obviously. This needs the context. This is same thing. Same thing. And that there. All right. So a lot of stuff going on there, but I think that's basically what we want. And so we can look now and see to what extent we're in the ballpark, right? Again, just looking through it now that we've done all this, I do think it's somewhat costly to do it the way we decided to do it. It's kind of cool. I'm glad I've done it once, meaning preserving the actual way that the human wrote the HHT rather than romping over it with whatever the computer would have generated for that particular in-memory asset. I'm glad I've done it once. It's kind of interesting. There are some costs to it. I feel like it's more fragile because, you know, I don't think, because text files allow you to put things in any order, it's hard to make something that does a clean diff style thing where you just look at two things in memory. Are they different? If so, write the whole thing out, right? That doesn't really work anymore because you got to do it like line by line. Like, did this line differ? And if so, like, save it or whatever, right? Now, I could imagine a way of doing this better, and that would be that for every line, what you would do is you'd essentially create a structure that was like, here is the version of this thing that just stores a string for every field instead of the actual field, right? And then when you do your data diff, anything that's different, you update the string, and then you rewrite the strings, the actual strings, so that you like load it all in as strings, you diff the data, and every data that changes, you change the string that corresponds to the data, then you write it all out. Would probably be like the more systemic way to eventually do it. But I think you kind of get into a systemic situation there where you're like, unless you're doing like a whole system this way with tons of different types of fields and everything, it's probably not worth the time to really build that out. But you could see a generic version of this that you could do, and it would be interesting. Like, I think that would be an interesting thing to make. So, you know, like I said, I hadn't ever really looked at that before, but it's interesting. So I'm going to go ahead and say, look, let's start playing around with this. Inside our tags files, where we've got like basegame.hht, what I want to do now is I'm going to create a backup of it. And the other thing that I need to do now is actually have a way that we can see what our output is. Because if I remember correctly, we never actually implemented that function. So in the Win32 file layer, we've got this sort of replace file contents, and it just doesn't do anything. Right? And so we need some way of doing this atomic replace, a way of actually writing something out and then replacing the one we have. So I need to open a file, write the data to the file, close the file, verify that that was fine, and then swap the two files so that the new one and the old one have like traded places. You know what I'm saying? So that's kind of what I want to do here. And the problem with this is that a lot of times you can't really, like, I don't know that Windows ever created what you actually want for this. So what you want to do, like the way you would normally do this in an operating system, is you have the idea of an unnamed file, right? Which Unix has. Like inodes do not, inodes don't have to have a mount point. They can just exist, right? So if you're working on a file system that has the concept of an unnamed file, then what you do is on the drive that you are trying to place this thing, you say, give me an unnamed file. Here's all the data, write it all out, finish. Did that work? If all of it worked, then swap it with this other file's name. Or if it didn't work, just forget that inode ever existed. Don't link it in and reclaim this free space, right? That's how atomic replace is supposed to work. Unfortunately, Windows, as far as I know, doesn't have a way to do it. And there are some issues related to how it does work on Windows. I'll try to sketch it out for you now. We'll kind of jump in here and I'll show you what I mean. So what we want to do now is we want to take advantage of the crappy version of this. The crappy version of this is, since you have to have all the files have a name, give me a temporary file name that I can use so that at least I know I'm not overwriting a file that already exists. And then when I'm done, I'll rename it, in. Again, no real reason for this file probably almost ever to exist at all. There are some times when you actually want this, which is give me a name that doesn't exist somewhere, but most of the time you don't actually want that. You want to do something different than that, right? But oh well. So this is what we would like to do now, is be able to do the atomic replace here. And the atomic replace, there's a couple different ways we can do this, right? But the very first thing we want to do is just call this so that we can have a temporary file name that suits the purpose that we care about, right? So what I'm going to do is I'm going to call this. And what you can see here is there's some really dumb stuff involved, right? But anyway, this unique thing here makes no sense for what you think about what the API is doing. If unique is 0, get temp file name creates an empty file and closes it. If unique is not 0, you must create the file yourself, right? Which doesn't make a whole lot of sense. But anyway, we want it to do that. We want to have it create the file and close it. So it's 0. And again, just to underscore how bad this API is, what you really want is you just want give me the file. So you want it to actually return you a handle, right? But again, I don't know if they ever added that. They may have added it finally at some point, but I don't think they did. I'll scan briefly to see if they did. There didn't used to be one. Yeah, I don't see it. So anyway, we're going to pass a 0 for that, but, again, that's sort of a separate thing. The path name is the directory that we want, so we need a way of getting the directory out of this. So we're going to have to do that part, right? So we need the dir name, and then the prefix string is the part that we are going to use for sort of making it clear that it was ours. So we'll just use Handmade hero, and this is going to be some kind of a file for a temporary file. Temp would be good, but we already have the HHT as a tag file. So we need some way of marking this as a temporary file. So I'm just going to say it's HH underscore for now. It's just a Handmade hero file and there's nothing else on there. So anyway, we need that prefix string. This has got to be a wide string because it's going to be calling this the W version is what I'd actually want. In fact, I probably should have clicked on the W version. Like so. So these are both going to be wide strings. The unique file number thing is just going to be 0 because we want it to figure that out itself. And then the temp file name is actually the return. They ask for it to be max path characters, which again is just dumb because that's not the largest it can be. And you know, what can you do? You know, Windows does what it does, so you know it should really be based on more information than that, because you know what the path name and prefix string are, so you actually know how long that would be. So what Windows should probably do is tell you how much it needs to generate the max path or something there. I don't know. Better still would be it just allocates it and gives it back to you and you free it. But 6 and 1/2 doesn't the other. Anyway, so we've got WCharT here, which is going to be our file name. And they ask for math pass plus a null terminator, which is that. So we'll give them that. And then we just need to know when we actually call this here, we just need to know what the directory name is. And the directory name is what's going to come out of the information that we were given. So we'll do that, and we'll use the uint that's returned, which is just to tell us what's going on here. Where's the return value? There it is. The return says the unique numerical value. If the unique value is non-zero, the return value specifies the same number. If the function fails, it's 0. So we'll just say, okay, let's if on that. Assuming this returns something, then we're in good shape. We should have the file name now. And so then what I can do is call create file W. Then I can call write file. And then I can call close handle, right? And we can write out this file. And if all of that succeeds and nothing goes horribly wrong, then after that's done, I should be able to swap the files. Right? So in order to swap the files, we're going to need to be able to rename things. In order to rename things, we need to call move file. It's not called rename in Windows. I don't, just don't ask me why. It's called move. So the move file function, I don't know if we need the extended version of the move file function. We might. Let's look at the flags. So we do need replace existing, but that's about it. So that's all we would do there. So we're just going to say like move file at that point. This is an if, meaning if everything succeeds, then we want to do a move file with replace existing. And again, this is pretty easy. It's just the existing file name and the new file name, right? Probably should name it this way, right? So we've got a file name that we're going to overwrite. We've got a temporary file name, so let's actually make those explicit. We generate the temporary file name. We try to create that file. If we do, it's going to look like this. So we try to do the create. We then try to do the write. And the write is going to determine whether we can do this. So we've essentially got like a... that. So that's roughly what we're trying to do here. And since atomic replace file contents is something that can easily fail, like anything that touches the drive like that is something that could just fail. The write could fail, the creation could fail, the getting the temp file could fail. You know, we have no idea. So when we do atomic replace file contents like that, it really should return here some kind of a Boolean value that lets it know whether the write succeeded or not. Because there's no other, it's not like the other one where we have an existing handle, so it can just set the flag on the handle. Like if you remember, the way we did that before was just saying, look, there's an error flag on the handle. We don't have the ability to do that because there is no handle. You're just doing one atomic replace, and then you're done. And so, you know, if we do it that way, then what we've got is that B32 there that should come back. That's the status of this thing, right? So it's like, okay, there's a result here. The result is going to get set depending on whether move file succeeds or fails, which I believe is a return value of just a bool, right? Either it works or it doesn't. And so it's true if it succeeds, usually. Yeah. So in the case where we actually get move file to work, then we want to return true that we were able to replace the contents. If anything else fails, we'll never get there. And then we're fine. So what we need to do here is say, actually I need to do this. Right, so we're going to try to create the file. Assuming it worked, we're going to try to write the file. And then we're going to close it no matter what, because we don't want to leave the file handle sitting around. And then we want to check, did it actually successfully write? If it did successfully write all the data according to Windows, then we will do the move and be done with it. Right? All right. So let's take a look. If we want to see how to create this particular file, so let's do the write file first since that's easier. So the write file function is pretty basic. It just needs the file. It needs the buffer, which is this. It needs the size. And unfortunately, well, this is a little bit nasty. It doesn't actually have the ability to do 64-bit writes, so we'll probably have to assert that. We already assert that in other places, and we will never be doing a 64-bit write, but it's just kind of a dumb aspect of it, right? So yeah. So let's take a look at that one. A pointer to the variable that receives number of bytes written when using synchronous file parameter. Write file sets this value to 0 before doing any work or error checking. You know what? I just... Overlap doesn't do 64-bit writes, does it? No. Oh well. So anyway, we can't do an actual 64-bit write here, and in this case, we're gonna have to ask for the bytes written because it looks like they demand that, which is not great. But oh well. Oops, and I don't know. Don't ask me why this is happening. So we need to actually pass that. And what we could do is we could make this a little bit squinkier. We could say, all right, well, you know, here's the bytes written, and maybe we double check this just in case Windows can return true in this case and actually return true that it wrote some bytes but not all the bytes, for example. So what we could do is say, all right, let's do this, and then we'll say, well, write OK we'll assume is false. And then we'll set write OK equal to bytes written equals size, right? What's kind of fun about that is if we do it this way, that actually means that now if you pass in an actual 64-bit number, this function would fail. Seems good, because then at least the person knows it didn't succeed, right? And we could also put this in here. Right? And so that way this, you know, if this was actually something larger than 32 bits and the bytes written comes back as however much it comes back, it would go like, hey, you couldn't write the whole file, so don't do the atomic replace. Good. Prevents data loss. Seems reasonable. So that's all good, and we're just down to create file W, which again is also easy. I will go ahead and, grab that out. And here it is. So now we've got the file name. We know that Windows gave us the file name, so that's easy. The desired access is just going to be a generic write. There is no reading of this file, so we don't need that access. Not that it would be a problem if we did, but we don't. We don't want any sharing at all. There's nobody else should be accessing this file for any reason in any way. So none of that stuff needs to be set. The security attributes in this case is going to still be 0. We don't have any security descriptor or anything like that we want to inherit. We want to create this file always, and we want it to be new, right? So what we'd want to do is clear it. And that's what this does. If the specifier is writable, the function overwrites the file, right? And so we do want that to occur. So we want create always. Technically, I think open existing would probably work because this function is supposed to create the file for us. So I think open existing would work here, but you know, oh well. So anyway, we've got all of that set. We then have creation flags and attributes and template file. There is no template file. So we're just down to flags and attributes. And the flags and attributes, I don't know that there's anything in particular that we need to set. Probably just normal. File attribute temporary might be something we would set, but I don't know that we really care. I don't think we care. So I'm just going to set file attribute normal for now and leave it at that. So we create the file, write the file, and then we're done. So really our only sort of difficulty here is we need to create some temporary buffer to store the well, not temporary buffer, we need to like parse the file name to extract where the path part of the file would actually occur. So we're going to have to actually do that part, and I believe we've got a file name thing in here where we look for like find last slash or something. Thought we did. Maybe not. So I thought we've done this before. And in fact, you can see it here. But I guess it's just called remove path. Well, that's fine. So if we go back and look in platform.h here, here's the platform file info for replacing the contents. I guess now that I think about it, that means we have the actual Unicode version of the file name, which is good. So we should probably preserve that, which means that, yeah, like, you know, in here where we do win3d open file, this part here is the existing file that we're replacing. So where was I? This is the existing file name. And so what we want to do is process that to find the end of the path. And, excuse me. So we need to just scan that for the last place where a slash would be, and then that becomes our directory name. So that seems fine, but just looking at it here, let's think about this. Bring me back to my temp file. Where's my temp? That's move. There it is. So what do they actually want? So interestingly, they don't even say whether it should include the trailing slash or not, so that's interesting. But since this should have the entire path in it already, I should just be able to scan for the last occurrence of a slash. and if there isn't one, then it's just nothing, right? So I should be able to do this. I should be able to walk this entire structure. And since this is UTF-16, it means we're looking directly at the characters themselves to see whether or not we have a slash. So what I would do here is say, okay, if starscan equals this kind of slash or that kind of slash, we'll support both. No matter which kind of slash we see, we will assume that then that is the last slash. So we'll find wherever the last one is, and then we will just temporarily update this thing to use that for the get temp file name, which is kind of squinky, but we can do it, right? So what we would do here is say, hey, existing file name, or rather, the place where the slash is, we're gonna overwrite with null. And again, this is why I hate null terminators. You're constantly modifying strings for no reason. We could have just passed as the length, right? If Windows took length strings are always better. There's like almost nowhere that you don't want a length string. But anyway. So we just can quickly do that, and that way we don't have to do any copying or anything like that. It's just existing file name that gets us the temp file name. And that would just work, right? So we can scan it, find it, swap it, and go. But again, it's just like really stupid, because if you use length strings, you never have to touch the strings to like extract pieces of them. You just pass the pieces. It's much more efficient. If you use null terminators, either you can't do it at all because poking in a null would be bad in that particular case for some reason, right? Because maybe multiple people need to use it at the same time. Or you're constantly doing like poke in a null, unpoke a null, poke a null, right? And the only alternative is copying the string everywhere. So you're constantly copying strings, copying strings, copying strings, copying strings. And you never need to, right? You're really just proliferating a tremendous amount of copying and or null poking, but usually more copying, because a lot of times you can't poke a null in. It's only like, this is one of the few times when that actually works. And so length strings just help, it avoids all of that, right? So, you know, it's tricky to see sometimes why nulls are a bad way to do strings, but they usually are, almost always. Okay, so let's see. Cannot convert argument 1 to LPC stir. That's because I put an A in there and I meant a W. So that's unsurprising that didn't work. Looks like that was all we need now. 3 arguments. Okay. Oh, right. It's move file exw that takes the existing argument. All right. So now we can try it, and we can see what's up. And again, now we just got to do a bunch of testing, find out what we screwed up. I'm going to go ahead and put a breakpoint there so that I can watch what's going on. Oh, it looks like we're still updating at startup. Interesting. So it looks like we're getting a issue here. What's this? How are we getting how are we getting an error here? So this is saying we got an asset index back, which we did, but that asset is not valid? it's a type 1 asset, which in our case is a bitmap. Oh. Whoops. Yeah, maybe we shouldn't have two fields named type. So the asset has a type which we're kind of using temporarily right now as a patch for our tag system. Forgot about that. Eventually that will probably go away, but it was in there as sort of a stopgap measure, and I completely forgot that we had done that. So that's not constructive. That type field has nothing to do with the one that we were actually talking about. So yeah, that was dumb. So the assert here that we're actually looking for, import. In this case, it's the HHA type that we're talking about. And that's really the only type that the asset should have had at all in the first place. But again, because we're patching around the fact that we haven't really finished up how we want to do our tag searches. I mean, it's fine, it works, but it's kind of crappy. We are just kind of using that tag, that primary category tag, as something that we use in a different way. And so, yeah, it's just dumb. But that's the way it is for now, and we have to obey it. So it looks like this. All right, let's try that again. So the import ran there, and that looks like we still got some problems there because we're not seeing this. That wouldn't have written the HHT, so this is just a straight up import, but it does look like we're getting some align point weirdness there potentially. I'm not quite sure, but the fact that I don't see that the fact that I don't see that there makes me think that's the case. Now, to be honest, that's actually correct, I guess. Because, yeah, the default is to not have any points. So actually, that's correct. Where do we add that default alignment point, and why did we add it, or when? Because, yeah, now that I think about it, that was just something that I guess we were adding during imports as an... I don't even remember where we were adding that. Do you folks remember where we were adding that? Here it is. So you can see here, we used to set this default alignment point, and we set this default alignment point anytime we went to write an image out to the HHA. And that's totally wrong now. Like, we don't want that at all. I'm going to look for any other... Yeah. So interesting enough, I think what we probably want to do, I guess, is when we are loading in, if we are doing an HHT out, meaning we're writing the thing, then if there isn't an asset, we just want to set a default alignment point, probably, right? So, because everyone needs a default, probably. I mean, we don't have to. We could force you to create one, but that seems kind of stupid. So what I would assume we would want to do here is say, all right, when we are processing these, if we're loading them in, like this, then if we have an asset without any alignment points, we insert the default one. There's a snafu here, which is that means there is no way to delete the alignment points entirely. Like if you want someone who just doesn't have any. But I don't think that should really be legal, to be completely honest. So yeah, I guess what I'd say here is if we go through this entire thing and said there were none, right? Like there just aren't any. Then we would maybe call this, right? It's kind of crude. Hard to say, but I think maybe that's what we want. So we'll just do here like no alignment points equals true. And if anywhere in here there was one, then we'd say that's fine. So we'd say if there's anything in any type field ever, so that this thing could be considered an alignment point, then it's fine, right? And when we do that spin through, it's just this there. All right, so let's see if that's a sane way to do it. And I don't know if it is, but you can see that restores the behavior properly so that now like things have that default alignment point. So I'm going to go ahead and just do a basic write out. Now, you know that I've saved, like I said, I saved a backup here of that file. And what I want to do now is I want to say, let's just try rewriting it without actually doing anything at all. So I'm going to do import and save here, and we're going to take a look at what happens. So we're going to call atomic replace file contents, and if I step in, I want to watch this Win32 code to see if it works at all. Let's see what the existing file name is. It's tags intro cutscene. That's correct, because the tags intro cutscene file, excuse me, the tags intro cutscene file actually does have no alignment points in it. So those will get inserted now, if that makes sense. Which maybe we do or don't want. Since we're going to replace this file, I'll copy that one too. Just so we've got it. And I'm not sure how I feel about that, because if things only need the default one, do they really need to get saved? You know, I'm not crazy about that. So here's a question. Can we do this in some way where this default would just happen automatically so that it's what's assumed? Like, here's a question for you. Suppose I was to get rid of this. Can we just call this on the initial setup? So in here we would say, look, if we're writing the file out, then, you know, we're writing the file out. If we're reading the file in, then we're reading the file in. We know we have those two separate paths. Maybe in either case, if there's an asset, we set the default. I'm just trying to think about how you would do this so that you don't actually need to specify a default as existing. Here's one thing I would say. I wonder if maybe that's something that's just better done in the query. You know what I mean? Like, when we actually go to get one of those points, should we just fill it in there? So when you do when you look for HHH, align default, should that be something that you just do separately? So like, where do these actually get used? Nope. So I'm guessing it's find align, and so for find align, maybe it's like, look, if the result type is 0, so we just didn't find anything. Maybe we say if the result type is 0, then we'll set the result equal to this. So if we're looking for complete type of HA align default, right? And the result type is 0. Then we do it. Does that help? Because that would get us out of the business of ever inserting defaults at all, right? That did not work at all. Wouldn't this have to be to parent though as well? Like, how was this working before? I'm not sure about that, because it feels like this, yeah, would have had to been a little bit different. But so if we call, the other thing I guess is for first align. Let's see where that's called. Maybe it's that function that we actually need to modify. Yeah, okay. So we probably shouldn't really be calling that anymore, but that actually looks like what we need. So for this, what we probably want to do is say, when you call get first align, we would say, look, the v2 result is going to be this. If the bitmap info align points 0 dot type is valid, then we get it. But I don't love this. And so I don't know how I feel about that going forward, but for now, I think that's more what we need. So then there'll be a default alignment, or should be a default alignment, although it didn't look like that worked, that would create, you know, a p% here where we we only get the, oops. We only get the p% in the case where there actually is a valid one. Otherwise, we'll assume the 0.5 for get first align. And that would be the same as having inserted the default, I think. So I'm not sure why that wouldn't work. Although, again, I thought find align would have been what we were calling there inside the entity system. So I'm not sure what's up with that. Because that should have been... so here's what we could do. Could also say that we just get... oh, so I was right. It is the toParent. That's why it didn't work. This was getting set to toParent because that's what toParent is right there. Okay. So yeah, when we do find align, we could assume that, like, you know, we set this, and you know what? I'm gonna return it to the way I was doing it before. I think that's correct. So if what you were trying to do was look for this, then we will give you a default, but only then. Better? Yeah. All right, let's see if that helps me. There we go. And so now those files should be the same. And so if I do import and save, good. I don't hit my rewrite case. So everything is preserved exactly. So then if I come in here and say, let's go ahead and change one of those alignment points, can I get it to rewrite it? Which is a little hard in the slow version of this thing. Let's see. Oh, I got to pick somebody first. So let's pick this. And I'm going to add an alignment point. So we'll get the toParent one here. I guess it should technically be like that-ish. We've got the base of neck. Should be about there. And then I'll do import and save. So we'll have to debug this more tomorrow, but now we can at least take a look, I think, to see whether this function works properly. I'm hoping that now we're not rewriting the other file. Yeah, we're rewriting base game. That's the part that I just fixed. So that should be good. And then we can see, okay, did we find the last slash okay? Looks like we did. Let's see what our existing file name is. Just tags, that's correct. Let's see if we got a temp file name. Looks like we did. So what is that temp file name? It's tag / hh7824.temp. Okay. So assuming that was okay, we'll go through here. We'll do our write to that file. Looks like the write worked. Close the handle. And if the write worked, then we will go ahead and do the move, right? So now we should have replaced the file with the new file, and off we go, right? So that all looked great. The only thing we might want to do here is, since it is something that contemplates a failure case, and you can see here where we've rewritten this file. It's different now. Since we're contemplating a failure case here, the other thing we might want to do in that function is that, if we didn't, if we couldn't get the replacement that we wanted, there is a point where this can fail, like somewhere right here, right? Where the temp file has been created, but we don't want it to be there, right? So this will remove it, but if we couldn't remove it, right? So if the move didn't end up going as planned, we want to do a deletion, right? We'd like to delete that temp file so that it's not hanging around on the drive for no reason. And so that removal call should be there for cleaning up. So delete file W, right? So we probably want to keep that in there. Let's go ahead and open up meld, which I think we've got, right? And let's just see what's going on with the files that we rewrote. So here's Handmade, and oops, here's the tags files. So let's take a look at the original, and then the updated version, and see what actually got rewritten. So looks like in here, right, you can see that we wrote out those two files, and oh, hey, look, everything else is the same. So it actually worked perfect, right? It's exactly what we wanted. There's the alignment info in there just so. And my only question is the 0, correct? Because I don't really know. I don't remember what the actual grids look like in that particular file. But everything else is fine. We didn't put our tabbing in here, and we don't have a \n. So I think we want to add that back in there. But other than that, it looks fine. So let's see if now, when we run, if everything works okay or if it's busted. And we'll go from there. Because remember, now it's still, we onload at the moment we have it hard-coded to call the import function, which is not probably something you would do normally, but that's still happening. So if I grab one of these right here, let's just see what we've got. Yeah, looks like it reloaded it just fine, right? So I think we're in good shape. So I'm going to go ahead and update that part to be able to insert those \n's. But other than that, I think we're in good shape. So now that we've got that sort of through line going there, yeah, I think we're happy campers. So in here, I'm just going to put 4 spaces. Not the cleanest way to do this. We could have a much more complicated system if we want to, but for now, that's fine for me. And the \n, so it preserves some manner of formatting there. All right. And the reason I say it's not perfect is because if you were really trying to obey the file, you'd have something that looks to see what the indent level is according to the user at any particular point and does that, right? So, you know, we're not getting into that level of craziness here, but you could imagine that being the case. So, all right, let's go to the Q&A now, and we'll finish this up tomorrow. Just like looking for bugs and stuff and anything else that we feel like doing. And then next weekend we can start on other elements, right? No, the worlds are generated procedurally. Do you think it is better to design for the top 10% of programmers or the majority in language or API design? Um, so I guess what I would say about that is it depends what you're trying to do. So I don't think it's a better or worse kind of question. It's a what is the purpose of this thing you're making kind of a question, right? Um, and so uh, if your goal is to make, like let's say you're making something like a scripting language for, you know, an operating system or something, then it probably doesn't make sense to design for the top 10% of programmers because it's kind of just a utility layer that's used by everybody, and a lot of the people using it aren't really even programmers in quotes anyway. They're sysadmins or something. And so, your design is should be tailored to who is going to be using this thing. If on the other hand you're trying to make a language for writing like large end user software, then I think it should absolutely be tailored to the top 10% of programmers because we've seen what happens when you don't, and it's horrible. I mean, that's like the web or something, and it's like unusable. It's not like unusably bad. I mean, it's just horrid. It's like using a computer from 1960. I mean, it's absurd. The only reason you know that it's not a computer from 1960 is because instead of printing things out as text, you get like a pretty graphical display. But everything else is exactly like 1960. It takes several seconds to process every request. It fails a lot of the time. It asks the user to intervene on things that are incredibly technical. Clear your cookies. Refresh the page. What? Like, what are you talking about, right? I mean, it's absurd that a user would have to even know what a freaking cookie was, you know? And so we've definitely seen what happens when you expect real software to be written by non-programmers, and that's what you use every day online, and it's terrible, right? So. In an old stream, you mentioned that you like having all allocators like push size go through macros instead of direct function calls. What's your reasoning behind this? Two reasons. One is so that they can cast based on the size properly. So for things that are not doing just a blind size push, that helps. But for things like push size which don't need to do that, the reason I like them to go through macros is so that they can provide file and line information during debugging. So if I want to know who's taking memory, if all I do is have a regular push size call that isn't a macro, I have no idea who's calling that. But if it's a macro, I can insert the file and line number in there, and that way if I track who allocated what, I'll know. So it's really to enable that kind of debugging. And then, of course, in non-debug builds, you just turn that off, right? So it doesn't cost you anything. Since there are a lot of questions, do you think I could interest you in a pair of zircon-encrusted tweezers? I mean, what I will say is that obviously zircon-encrusted tweezers are the best kind of tweezers. They're high quality. I don't know if I'm quite ready to retire to Montana yet, but when I do, I will absolutely get a pair of my own zircon-encrusted tweezers. Would you move to Clang and implement custom build tooling? Probably not with Clang, because Clang is really unwieldy and gross. If you ever try to open up the like internals, you're like, oh my god, what exploded in here? So I probably wouldn't do any custom tooling with Clang. If I was going to do custom tooling, I would, write my own program of some kind. Clang's a nightmare. May I ask a larger off-topic question, or should I say it tomorrow's pre-stream? Well, you might as well ask it, and then we can see. Is there anything like operating system garbage collection? My professor talked about not needing to free calls to malloc due to something like that. I would imagine he has no idea what he's talking about, but I'm not sure either. Well, I guess what I would say is it depends what your professor was talking about, but yeah, no, there are that does exist. It's a little misleading to call it garbage collection per se, but it is sort of a thing kind of like garbage collection. Traditional garbage collection means that periodically a supervisor of some kind interrupts your program, looks to see what memory is reachable and unreachable from things that are currently known to the program, and then returns those things that are unreachable to the free pool of memory, right? That's traditional garbage collection. That, in a literal sense, does not exist typically in operating systems. However, a light form of that does. Any modern operating system now has to understand what resources are used by each process in the operating system, so that if that process tries to do something illegal, crashes, runs out of control, it can be contained and stopped, right? So a limited form of garbage collection, which is to say, it's probably better, it'd be better to think of it less as garbage collection, more as an arena. You can think of your process's resources as all being in an arena marked for your process. And when your process terminates, it will all be freed, right? File handles, memory allocation, I/O ports, whatever, right? All of that stuff is binned into your process when you open it or allocate it. And when your process closes, it all gets closed and freed. So when you call malloc, if you want to reuse that memory again yourself during the course of your own run of the program in the same process, you need to call free. If you don't ever need to do that, if you just use the memory and then exit, you don't need to call free because the operating system will clean up that memory by default. If that's what your professor was talking about, they are correct. And that's true in any modern operating system. In antiquated operating systems where computers were less powerful and things like that couldn't really happen, then this was not true. So. So let's go ahead and take the last one from Gary Johansson. I talked to one of the Handmade debug teams. What's a Handmade debug teams? I don't know. And they made it sound like it would be doable to expose all debug symbols on an API level. This seems like a very powerful thing since people could build custom plugins on top of the debugger itself. This seems very powerful and very leverageable. Is there anything wrong with that? Is there some reason you know a Visual Studio does not expose debug information to an API? Um, no, actually, the opposite is true. Visual Studio does expose debug information as an API, or more appropriately, Windows Tool Help does. Visual Studio is actually built on top of Tool Help, and there are PDB accessing things in there. So where's the actual? So I guess Tool Help doesn't have it. Tool Help only has the process inspection. So maybe I'm wrong about this. I thought there was a way to do that. I thought there was one of these, but maybe there isn't. Yeah, here it is. So they do ship these. They exist. Tool Help is the one for inspecting processes and threads. I, for some reason, thought that the PDB stuff was in there, but it's not. So it's all here, right? You can access it. Someone said debug help. Yeah, here you go. Yeah, debug help. Sorry, I got the, yeah, tool help was one to do it. Yeah, okay. So, it does exist. That's the thing. Yeah. All right. That looks like about it. So I'm going to go ahead and close it down. Okay. Thank you, everybody, for joining me for an episode of Handmade Hero. It's a pleasure coding with you, as always. That was a big push we did several weekends of making like a clean text in-out thing that could allow us to edit it in both directions, and it was pretty cool. It seems like we've got it working now, which means we can mark up our files all we want inside the in-game editor, which I probably will do tomorrow. And then we can test it out, make sure that we can edit everything cleanly and that it doesn't like corrupt everything and degenerate and get horrible or anything. So we'll do that tomorrow. And that's also good because that means all of our assets will now be usable. And we can play around with them a lot more flexibly than we used to. And it also puts us in a good position to start thinking about how we want to do the tag querying and updating and stuff like that too, which we'd like to do. And since we have some things that we haven't figured out how we're going to really label and use yet, like the ground cover and stuff like that, that may be a way that we can figure out those parts of our system now, that we have an easy way to edit and mark things up. We can try marking it up a couple different ways and query it in the file in the game and see, does this work or is it cumbersome, and so on. So that's what we'll do tomorrow. And we still would like to add sounds and stuff, so that'll be a little bit further down the line. But for the moment, let's just play with the bitmap stuff, make sure it's really working, make sure we're happy with everything, and then we can move on. Hope to see you back here for that tomorrow. Till then, if you want to follow along with the series at home, you can always pre-order the game on handmadehero.org. If you pre-order the game, it comes with the source code so you can play around with it and do your own experiments. We also have some other stuff at MileyRocket if you might want to check it out. You can always click on the Handmade Hero head And we've got stuff here. We just released Meow the Infinite, which is our new comic. If you like web comics, you might want to check it out. Just click on Meow the Infinite, and off you go. There's also my blog and the My Rocket homepage. Everything's up there. So yeah, don't be afraid to click on the little Handmade Hero head. There's good stuff in there that you can explore. Until tomorrow, that's it for today. Have fun programming, and I'll see everyone on the internet. Take it easy, everybody.